Hello everyone, in this video I'll be talking about the dimensionality reduction using PCA. So what is dimensionality reduction? As the name implies, it is the process of reducing the dimension of the dataset from high dimension into lower dimension space for more meaningful representation. Or in other simplest way is to have a few number of the most relevant and representative features of the dataset. There are two basic types of the dimension in which they are feature extraction and feature selection. In this tutorial, the focus will be on the feature extraction using PCA. So first of all, let's import the packages. Okay, now I'll import the dataset and assign it to DF. You will find the data source in the description if needed. Okay, now let's check the info. Okay, we have 776 instances and 27 attributes. Okay, the data is fair enough. And looks like most of them are numeric. Okay. Yeah, we have 23 for float and 3 for int and only one object in which its location ID. There are several ways to deal with categorical variables or object. We can encode them using either label encoding or one-hot encoding, so it's actually depends on the type of the categorical variable, whether it's ordinal or normal. Okay, so but here it's just an ID number, so it will not give us much contribution in the predictive modeling, so we'll just drop it later. Okay, now let's see how the data looks like. It will return to us the first for instance. Okay, sector score, location ID. The scaling looks different, so we'll check this later. This is the risk is the class attributes. Okay, so let's first drop the categorical variable. Okay, drop. Okay, we just use any place to replace it, no need to assign to the data. Okay, now let's check if there is any missing value. Okay, there is one missing value. Usually for missing values, it can be replaced either by using machine learning techniques, for example KNN imputation, okay, or there is packages like mice, or you can just use any simple method in statistical like mean, median, or mode, but again it depends on the dataset. So here we'll just drop it, as it's not it's only one missing value, so it will not affect the dataset. But if it was like more than 50%, you will just replace it, so you don't lose much information from your data. Okay, we'll just use drop now to drop it and assign it again to the dataset. Now we'll check it again. DF Okay, it's gone. Now let's see the description of the data. Okay, as I said before, looks like the data is not scaled because you can see here the maximum for sector A is approximately 60, and in bara A it's 85, score A 0.6, bara B 1264. So yeah, looks okay. Yeah, it has a high range. We need to scale this so it can become between 0 to 1 because BCA finds the direction based on covariance matrix of the original attributes, meaning that if we didn't scale the data before applying BCA, we will get a misleading result. Okay, so now we'll check the class balance. Okay, for class 0 we have 470, for class 1 305. Yeah, looks similar. No need to do any resampling techniques, so we'll just leave it as it is. Now we'll indicate the target column and assign it to Y. Okay, for the rest of the data, we'll assign it to X and just drop the class attribute. Okay, now for the scaling part, we'll create a scalar object so we can use it later to fit the data. Okay, so I will use here min-max scalar. However, you can choose anything you want. You can use standard, you can use normalized, so it's up to you, and it also again depends on your data set. Okay, now create an object, create an new data core scale DF. So okay, okay, we'll just apply this for the rest of the data. We don't want to apply it on the class attribute, so we'll just leave the Y outside of this. Okay, here it looks yeah, we need to convert this back to a data frame. Okay, it's an array. Okay, so we'll convert it back. Yeah. Okay, so first of all, because when we use transform, the name of the columns will disappear. So what we need to do, we need to create this so we can convert the column names back. Okay. Okay, now creating or replacing the array to data frame. here you put columns equal to names, so we can get it back. Now skill df. Okay, see, we have all the data set except for y with the names and also scale. Okay, let's check it to see if it's scaled or not. Yeah, the maximum for all of them is between 1 and 0. Okay, now we'll create a PCA. Okay, to generate a principal component, we need to fit the PCA into the dataset. We just scaled, so scaled df. Okay, now okay. Okay, this is the highest one. Okay, for the ease of representation, we'll use visualization to see how many attributes we need for the PCA. So we'll use plot. Okay. Okay, looks like there is a problem with the letters. Okay. Okay. You can see here that between 0 and less than 10, this is the most representative features, as after 10 there's no improvement. See, the line is straight. So approximately it looks like it is in 8. So we'll create an PCA with 8 components. Okay. So PCA number of components. Okay. Now to generate the principal component, we will use fit. I will fit the data on the previous scaled data set. Okay, because it's an array, we need to convert it back into a data frame. So scale dx. Okay, now let's check. Okay, so this is the new dataset. It has only 8 attributes because it's comes from 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now let's check the information. Yeah, it still have 775 instance with 8 attributes. Okay, let's split the data sets so we can build the predictive modeling and see how good the PCA on the modeling part. Okay, and if it will decrease the accuracy or give us a good accuracy. Okay, we'll use train test split. Okay, we will use logistic regression as a predictive algorithm. Okay, you can choose anything you want. Okay, we use LR. Okay, now let's fit. We'll use only the train set to fit the dataset. Okay, now for the prediction part, we'll use the test set. So lr dot predict pre. Let's check the accuracy using the accuracy score. Okay, it gives us 99%. Looks like PCA do really good in this dataset. So maybe in other videos we can try other dimensionality reduction technique, and we can do a comparison between those and see the different effects on this dataset. So if you like this video, please share and subscribe for more videos. Thank you very much.